This is Sample 6, Video 1. This sample is the most interesting in my opinion due to the sheer amount of activity seen in the sample jar. If you recall the location of my introductory video, you'll be surprised to find out how it changes with Florida's dry season. In fact, that full body of water has dried up into small puddles. So that begged the question, what else has changed? And more importantly, what microorganisms can we find with this uncovered topsoil? In this sample, there were more macroscopic microorganisms, as I like to call them. There were many shrimp that I have not identified, and even a planarian who was so cute. A lot of beetles and other worms and bugs and things that do not go under a microscope. However, on the glass itself, I thought there was a large number of copepods, to which I got extremely excited. I wasn't wrong, there were a few copepods. However, there were more ostracods, which is what this video will be about. The actual definition of a copepod, better known as a seed shrimp, is a bivalved arthropod with up to 8 pairs of limbs in adults, along with copulatory limbs and a furca, all of which are enclosed by a bivalved carapace with no growth lines. Yes, that was a lot to take in at once, however, let me describe it to you as we watch videos of ostracods. Like I mentioned, there were a few copepods on the glass. They're extremely quick, but I managed to catch one. If you would like to know more about copepods, please refer to my Sample 4 Video 2 post. In this video, however, the female's egg sac is quite prominent, which was interesting to see. This specific copepod was also turned upside down beneath the slide, allowing a clear view of its legs. Now onto the seed shrimp, or the ostracod. To the naked eye, this crustacean resembles a jumping poppy seed. They are no more than 1 millimeter in diameter. When placed onto a slide, their appearance becomes more complex. When they lie dormant, their outer shell, known as the carapace, is closed. However, if you look closely, you can see the separation of 2 plates, which is why the ostracod is a bivalved arthropod. This outer shell encloses 8 pairs of limbs and the antennae, which can be seen when the ostracod becomes active. For this footage, I added a drop of 3% methyl cellulose solution to slow down the ostracod's movements and accentuate their inner characteristics. The 5 pairs of legs and antennae can be seen clearly. As I mentioned, I collected this sample from the bottom sediment of the lake, and so I assumed all of the microorganisms I encountered would be benthic. There are key differences in ostracod species and their habitat preference. These differences can be seen in their morphology, but also in the way they move. The ostracods I collected seem to be crawling more than swimming, which supports the claim that they are truly benthoic. Benthic ostracods, in comparison to species that swim freely around aquatic plants, are able to adapt more efficiently to environmental changes, like floods and droughts. The most common benthic ostracod in Florida is the Cypridopsis vidue. They feed on a combination of algae, cyanobacteria, along with yeast and molds. Most importantly, they feed on organic waste, which is essential for maintaining the ecosystem. Ostracods are also used as proxies to determine climate change cycles and graphing pollution levels. Since benthic ostracods adapt to seasonal changes, they are also indicators of the salinity index in that environment. I hope you enjoyed this video. Once again, I have linked all of my sources in the description, and be sure to stay tuned for more.